Okay, since this is an upper triangular matrix and the eigenvalues are sitting on the main diagram, so we'll start with the first eigenvalue 5, second eigenvalue 3, third eigenvalue, and the fourth eigenvalue 2. Now to compute corresponding eigenvectors, so we form A minus lambda 1 times identity, so A minus 5 times identity, and then times V equals 0, and that means I have to subtract 5 from each main diagonal. So then this is going to be 0 when I subtract 5. This is the same. 0, this is negative 2, 1, negative 2, and this is 0, 0, and this is negative 3, 0, this is 0, 0, 0, negative 3. And then I will reduce this to see the free and basic value. Okay, so let's start with this. So you see, this is the first entry here is 0. So this is not going to be, everything below is 0. So that's not going to be the pivot. So I will go to the next one and then make the entry. So this is like pivot here, and I will make the top, because every entry below is 0. So I'll make the one above 0. But we can also do this because the first one is a multiple of 3. So if I can just divide the first column by negative 3, this will just give me 0, 1, 0, negative 3. And this will be 0, negative 2, 1, negative 2. I'm not changing the other one. Actually, I can just divide the third and the fourth column also by negative 3 to make those 1, 1. It will be easier to work with 1. So 0, 0, 0, 1 right here as well. Okay. Then to continue here, so I will make now just replace the second row and the first row, replace them. So this will be, or I can just make this entry here to 0. If I started from this number here, I'll make everything below 0. So multiply by 2 and add it to the second one. So 0, 1, 0, negative 3. And this will be 0, 0, and this is still 1, and I multiply this by negative 2, so that's positive 6 minus 2, that's 4. And these ones are the same. This one are the same here. Okay. Now I will go to this position right here and then make the entry below 0, and that will just be 0, 1, 0, negative 3, 0, 1, 0, 0, 1, 4, and this is 0, 0, and this is 0 as well. And then I have this. Okay. Now I can make everything about this entry 0, which is on this position here and this position here. All I need to do is multiply by 4 and multiply by 3, multiply by negative 4 and multiply by 3 to make them 0, right? So everything else is just going to stay the same. So 0, 1, 0, and this will become 0. This is 0 as well, and this one is completely 0, and this one is going to be 1 right here. So, and now we can identify the pivot position. So that's 1. This is, and this is 1, right? So then, if you rewrite this system, so you get x2 equal to 0, and then you get x3 equal to 0, and you get x4 equal to 0. So x1 is free in this case. So therefore, I can write it like this. So the v, let's call it v, x3 0, x3 0, x4 is 0. So therefore, this is x1 times 1, 0, 0, 0. Therefore, first eigenvector is just 1, 0, 0, 0. That's that. Now, to look at the second one, the second eigenvalue was 3. So now I have a minus 3 times identity. And this is subtracting 3 from the diagonals, which is 2 here, negative 3, 0, 9, and then 0, 1, 1, negative 2, and then 0, 0. So I subtract 3 from here. Well, this position was 0. And then when I subtract 3, this is negative 1, 0, 0, 0, 0. This is 2 minus 3, negative 1 here. Okay, now I need to make this. So this is going to be, okay, let's see. I can choose this to be my pivot position here. And then, okay, let's keep this for now, like this. And then 0, 0, 1, negative 2. So I can make this guy, this entry right here, 0 by just adding it. So 0, 0, 0. And this is negative 2. And then this is the same. Now I can use this negative 1 to make everything about 0, which is going to be, okay, so just adding it here. So this is just going to turn into 0 basically. Nothing else is changing. So this is 0. This is 0 now. This guy is also 0 now. And this will just be, let's make this one as well. Okay, so now what we have here is, this is my pivot position. This is my pivot position. This is my pivot position. So rewrite it. 2x1 minus 3x2 equals 0. And then x3 equals 0. And x4 equals 0. This will be 1, 2, 3 over 2 x2. So now if I write the vectors, I will do 3 over 2 x2. And then x3, x4 are 0. So x3, okay, this is x1, this is x2, or 0. Then I can just x2, and this will be 3 over 2. This is 1, this is 0, this is 0. And this will be my second eigenvector. So 1, 0, 0. Now for the other one, I have a minus 2 times identity. This is subtracting 2 from the diagonals, which is 3, negative 3, 0, 9. And this one is 0, subtract 2, so this is 1, 1, negative 2. So subtract 2, this is going to be 0, 0. And subtract 2, the last one is also 0 right here. Then I can just divide the first row by 3. So this is 1, negative 1, 0, 3. And then this is 0, 1, 1, negative 2. And this last 2 are zeros completely. My pivot position is going to be this guy. And I can make the second pivot position is this. The second pivot position is this. And the last two doesn't have pivot position, but I can make the entries about 0. So let me do that. So I just need to add it, right? When I add it, this is going to be, this number is going to be 0. This is going to be 1. And when I add it, this is going to be 1 as well. So now I just need to rewrite this. When I rewrite it, it's going to be, okay, x1. And then plus x3 plus x4. And then the second equation is x2 plus x3 minus 2x4 equal to 0. And x3 and x4 are free. So then we're going to get this. We're going to get x1. And then we have x2 equal negative 2x4, yes. So then and this is really just turning into this. So the v is going to be, so x3 minus x4, and x2 is x plus 2x, and this is x3, and this is x4. So now we'll write this as a combination of two vectors, which is -1, -1, 1, and 0. 4 is -1, 2, 0, 1. So then the third eigenvector is, so this is going to be v3, this is going to be v4. So it's -1, -1, 1, 0, and then v4 is -1, 2, 0, 1. So we have 4 eigenvectors, and now we find a corresponding eigenvectors, and we have exactly 4 of them as well. So then p, so this is diagonalizable because now we have this. So we have p should be 4 by 4, so we have v1, that's our p, and then our d is just the diagonal matrix, which we have 5, 3, 2, 2. So these are zeros. And then p is just going to be, just going to have the column v1, v2, v4, which we founded. And those are the eigenvectors. So yes, so this matrix is diagonalizable, and we have the p and we have the d as we just found it.